Hey guys, Ms. Gosling here. In this video, you are going to learn how to add error bars to a graph, and you're going to learn how to find the uncertainty in a line of best fit. So what you can see on my screen is some fake data. So I have a velocity versus time graph. I have my fake velocities, I have my fake times, and I've written here some errors. The errors are also completely made up. That is going to be your job to figure out what your error is in your IA. So what I'm going to do is I'm going to start by adding error bars to my graph. And to do that, I want to go to plus and go to error bars. And you see some random error bars are what popped up. I, of course, do not want their random error bars. I want my error bars. So let's start with my X. I'm going to double click my X error bars. And what's going to pop up is this lovely chart. And I want to go down to this charts option so I can change some of the important information about the errors. And I'm going to go ahead and move this video so you guys can see a little more clearly. So right now we have this at standard error, whatever that means. I want to use a custom error because I want my error bars to fit the data that I have. So I'm going to click specify value. My positive error value is going to be the error in time here. So I'm going to click on 10 and go down to 2. And I'm going to want to do the same for my negative error value. Excuse me here, let me click the right column this. And then I'm going to go ahead and click OK. You can see my error bars have popped up. They are different for each level of my IV, for each of my X values, and they match the lengths that I have for my errors here. I can do the same for my Y values. So again, I'm going to double click. I'm going to stay in this charts little picture option thing, and I'm going to scroll down, hit custom error, specify my value again, and I'm going to go ahead and click this column and this column. Obviously, your errors can be put anywhere on your spreadsheet that you want them to be. Here's where I put mine. And again, you can see my errors have been put in. I can see what my error bars are, and I have a super lovely graph here. Now what I'm going to do is put in my line of best fit, and I'm going to go ahead and put in my maximum minimum slopes for my line of best fit. And that is where, and we're going to use our error bars to do that. So let's go ahead and start by checking our trend line box as always, and double clicking our trend line so we can edit it. And you can see I'm already in the place that lets me change the type of trend line and display my equation. So I just want to display that equation on the chart. And I'm also going to go ahead into the paint option and just change the type of line and make it a nice solid line. So instead of making it this dotted line, I'm just going to make it a nice, easy straight line because it's easier to see. And we'll see if it decides to actually listen to me. There we go. Okay. Next, so now what I have is I have a lovely graph with my line of best fit. And of course, I will want to, and you will want to change this to V and T instead of Y and X, since that's what's actually in your graph. But what I need now is the error in my slope. So usually you're going to be reading some kind of slope value from your graph to figure out what your conclusion is in your IA or in other experiments that you do. And you need to be able to give me some error margin for that value. To do that, I am going to find the maximum and minimum slope of my graph using my error bars. So what I need is I need my error in V. And what I'm going to do is I'm going to pick the smallest possible slope and the biggest possible slope. The smallest slope is going to start at the with adding the maximum error to our smallest point. So 0.5, or so 0 and 0.5. And then our final point is going to be our last X and Y value minus their error. So instead of being, so we're going to keep our 5 the same, but instead of saying at 51, we're going to subtract 3 meters per second to give us our kind of minimum value for that. So again, the maximum for our smallest number and the minimum Y value for our biggest number. So we're going to go from 51 to 48. And with my 51 to 48, what I'm going to go ahead and do is add that line to my graph. And to do that, I want to go ahead to that chart design tab. So I click in my chart, go to the chart design, and hit select data. And what I'll do is I'll add a series. So what I'm going to do is I'm going to give this a name. It doesn't really matter what that name is. In fact, I'm just going to call it 2. My x values are going to be these two guys. And my y values, I'm going to go ahead and click into the two values that I have found here. And you will see I have added that to my graph, and I can find the line of best fit for those values. So I'll go ahead and click trend line, and you can see that's a nice little dotted line. I'm going to go ahead and look at my other options for this and just change it to a solid line, because again, I like it to be nice and easy to see. And I'm going to go ahead and add my equation as well. So this guy goes with this red version of our trend line. And here we go. I'm going to do the same for my y value, or for my maximum. So right now, what I know is that my slope is 10.486 meters per second squared, which we know are the units just from what's on my x and my y axis. And I know that the minimum that my slope could be with my data and my limitations is 9.5. What I need now is a maximum value. So again, I have kind of what I think it is, what my minimum value is, and I need my maximum. And to do that, I'm going to do the exact opposite of what I did for my minimum. So instead of taking the largest possible thing I could have for my first point and the smallest for my last, I'm going to flip that. I'm going to do the smallest possible number I could get for that first point. So it'll be that 0 minus my error. And I'm going to get the largest possible value I could get for my maximum point. So this 51 plus my error. And so let's go ahead and do that. So 0 minus, so we have 0 and 5 still. I'm going to do 0 minus 0.5 or negative 0.5. And we're going to do 51 plus 3 or 54. And again, I want to add that to my chart. I'm going to click in my chart, click chart design, select data, add the series. I'm going to call that guy series 3. My x values are, of course, going to be these same x values. And my y values are going to be these two guys. And you can see that has now been added to my chart. And I can double click it and do everything that I like to do with that. So I can add a trend line, make it linear, and I can change I can change it to a nice solid line, and I can add my equation to the chart. You also probably would want to change the color here just because it's a little hard to see. So what I have now is I have my maximum slope. So if I was trying to get data from the slope of my graph, what I would say is that, so this graph, being a velocity versus time graph, I know is going to tell me, I know that my slope is going to be my acceleration, right? Because I know v is equal to u plus at, or b plus mx, as you might be more used to seeing it with your equations for lines. So what I know is that from my data, my acceleration in this situation is 10.5 from this equation, and that's our expected value. But we know that it is somewhere between 9.5 and 10.9. So we have kind of a minimum acceleration of 9.5 and a maximum of 10.9, with our expected value being about 10.5. And so what that allows you to do is that allows you to switch from having kind of just a number, which is fine, but really not what we do in science, right? Because in science, we need some sort of margin of error, since there are always errors in every measurement. And so what this is saying is that's acknowledging how those errors affect slopes and graphing, as well as just raw numbers. Now, this is something that I'm going to be expecting to see from you in every single lab that you are doing. So whenever you are having a line of best fit of some kind, you should always give me the maximum and minimum slopes, as well as kind of what your data says the slope is. And again, that is just to acknowledge that your data has errors in it, because this is the real world and there are always errors. So folks, it is your turn now to give this a try. Best of luck and happy solving!